Alrighty, so hello and welcome. I wanted to get a little bit of time into your practicing. I've been kind of procrastinating, I guess. Um, not doing my work here, so here we are. I have another LeetCode problem called split linked list into parts. Let's give it a shot, see how it goes. Also, I'm not gonna be speaking too much because my voice kind of aches. No Python though. C++. So, reading. Let's see, interesting. Hmm. 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 Interesting. So, this isn't too bad. Can write a subroutine that breaks, basically pulls the first, we'll call it X elements from the list, splits the list into two pieces. First X elements in one list, and then the rest of the list. And we're going to push that into, or that first part of the list into an array. And then we can write a subroutine that just says, depending on what k is, divide the number of nodes we have left. We want to count the size of the list, I think, initially. So we just need a routine to count it as well. Divide by k. If it's not evenly divisible, then we're going to round up and take that many elements for the first section, and then decrement k by how much we took off, and decrement the number of, or excuse me, decrement the size by how many took off, and decrement k by 1, and keep repeating until until the number of nodes that are left are divisible by k. and then we'll make the list that amount until we're done. Oh yeah, we'll do it that way. Well, simple. Have a find length subroutine. I don't think you can actually have a const pointer. I don't know if you even can. Could you? I don't know. Let's see. I don't think so. Excuse me. Oh, you can. Huh, no kidding. Okay. Well, we'll try it, see what happens. Excuse me. Are we doing 7 minutes? Okay. Oh, it works. No kidding. I guess you can use const pointers. Alright. Fair enough. Have our subroutine. No. Yeah. We are gonna modify this here. We'll return a tuple as well. One of a few things, I think. 2 different list nodes and... Well, we can... Yeah, we could just do that. That's fine. That's fine. Okay. We're going to say... Hmm. There's a tricky detail here where we need to make sure that the previous node, which is going to point to this ret2 node, that previous node, that previous node points to the null pointer if it's not itself a null pointer. Yeah, do that. So breaking these lists up into pieces. Now the degenerate case of h is a null has a null pointer. Null pointer, null pointer. Null pointer. So none of this would happen. And this wouldn't happen. You just get null, no. I think it works okay for null pointers. Okay. Okay. Yeah, so while k is greater than 0, we're going to say amount, we're going to say excuse me, start with k divided by, no, it could be k greater than 0, also total greater than 0. Yeah, k greater than 0 is fine too. Excuse me. Yeah, just say k is fine. If we're not 0, set the amount to the ceiling of, yeah, well, let's do it this way. Trying to do this in a way that's clever, but couldn't really come up with a good way. So we're going to process each piece. One by one, sequentially. Probably could parallelize this too, by the way. If I really wanted to. Whoops. See what happens if we do this. Oh, it worked. So these don't need to be pointers. Interesting. Excuse me. Okay. How are we doing on time? 18.5 minutes. Ooh, wrong answer. Ooh. Okay. Uh oh. Oh. That's also my mistake. Forgot to do that part. Forgot that part. There we go. Kinda wanna run some randomized test cases. Yeah, we got a few minutes, we could do that, sure. I don't know if that's a good idea to do that actually. Let's try all these. That's probably random enough. Oh. Alright, we'll try some random test cases. Probably I could write a program to generate test cases that, like maybe I could just specify the format of the test cases that I need. So we could say something like we want, you know, like nesting for the arrays, and then I guess you could say something like, how many arguments do you need? Yeah, I could maybe design a test generating program. That might be interesting. Generate randomized tests, so I could test my LeetCode problems quickly. Well, yeah, you can get like you can write like a more abstract thing where you can specify the format of each test, and then give some parameters for each of those formats, right? Sort of the randomization parameters. That's an idea. That might save me some time in the future. You know, so I don't know if I'm going to be creating these randomized tests. But for now, we'll just copy paste these. I don't even know Generate test cases. Special. Say version 1. I don't know. Yeah. Sure. Yeah, there's gotta be a way to handle this where I can use a test case format of some kind. Maybe we should parse a configuration file. Maybe JSON file. Could parse a JSON file that specifies the format. And yeah, that might be better than trying to, like, how do we give input to our program in order so that it knows how to communicate with the program, so it knows exactly what format I want my test cases to have. Because we can code up we can automate that part, but the thing that really can't automate easily is the format itself. That we have to sort of give as input. And the question is, how do you give that input? Maybe a configuration file is fine. So you write one program, and then for each test case that you want, you can configure it a configuration file that you consume by this program. That might be better. Okay, but then what would this configuration file say? I guess you could have which kind of test cases do you want to produce? You might want levels of nesting in your test cases, which is maybe tricky. How deep do the levels of nesting go? Yeah, you could do that. And should you have empty nesting or not? What's each element of your, if you have an array, you could have multiple possible elements of the array. Is the nesting fixed or is it variable? That's another question. So like a multi-dimensional array would probably have fixed nesting, but something that's supposed to be testing like sort of a highly nested data structure might have nesting. You might have also even a way to generate like binary trees, right? That might have some nesting. Might have the null values. What are the kinds of values you could have as the inputs as well? Those are some things to think about. I might get into that. I might do that one day. Just take some time to code up a testing program. You were taking so much time to do it. Are you teaching what? It's a pretty basic question. What's up, John Peter? Welcome back. Hope your day's going well. Welcome. I think this is done. But what did you want me to? What? I think this actually we could probably just go for it. Let's go for it. Let's do it. I should have tested it. We got it. Okay. What was the? No, I wanted to test it before we submitted it. How are we doing on time? 26 minutes. Taking so much time talking, teaching or what? I already did it. I'm done. What do you mean? You give me a hard time for it. It's already done. Let's see if we can get a faster score though. It's pretty slow. No, not really. Huh. Why is it so slow? I don't know. Can we do this? don't think generating test cases is necessarily very basic. No, it's still slow. Why is my solution so slow? I'm so disappointed. Hmm. 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 I don't know, man. I don't know. Alright, we can go to the next question though. That's fair. How are we doing? 27 minutes? Yeah, I wanted to generate some test cases, but I don't know. We'll come back to this. Well, I'm strongly considering writing a program that consumes a configuration file, and that configuration file allows me to specify test case parameters and then variable parameters for those test cases, for the different properties of those test cases. Try to figure out a way to do that. I don't know if we should use TOML for a configuration file, or if we should use like JSON. I think JSON is overall reasonable, but we'll come back to that. So let me go to the next question. Thank you for watching. I'll talk to you soon. And I guess, assuming this is mine, runtime 3 milliseconds, fast to 96.858%. This is mine. Yeah, very good. That's good. Mine is not 3 milliseconds. For whatever reason, mine's a little bit slower. I don't really know why. Well, you know what? Actually, if you want, what we can do, we can try to go faster. Let's give it a shot. Let's see if we can go faster. So, I think this is cleaner to do it this way, but you can break this down, and you can copy pasta here. Unroll, quote unquote, unroll the loop. Let's see. So, so this would be A and B is ret 1. Let's see what we can do. Let's see if we can try to make it faster. Yeah, mine was not 3 milliseconds. No sir. No sir. Let's see. H is current head. Let's see if this compiles. Also, no disrespect, just felt like it to say. That's okay. That's okay. Now X is the amount. Let's see. A. Oh, right. Oops. Oh no. So what happens when you hit the insert key? I'm curious if this will even compile. So we'll find out. Okay, is it still correct? Okay, a little bit faster. One millisecond, not much better, but a little bit. And now the question is, I mean, we could unroll this one too. Well, I'm not sure about that. How about this? secondly, actually, you may have made the question complex, which it's not. Oh. I made the question complex. And how do you figure that? How do you figure that? And we'll say... Okay, one more time. Oh, 4 milliseconds, okay. That's better. I could not tell you why that would be the case. Why that's the case, I don't know. I couldn't tell you. But why do you think I made this complex? Oh, now it's 15. I think it might be random whether or not this is fast or slower. Yeah, I think that's just kind of random whether or not it's fast or slower. Okay. But still, it's slow. It's 1 millisecond slower. Slow. It's slow. I don't know, man. That's 4 milliseconds. It's pretty good. It's pretty good. Alright, that's good enough for me. We don't need to mince over milliseconds here. It's all right. It's okay. Why do you think I made this more complicated? I thought I made this pretty reasonable. It's pretty simple. We just split on the first nodes, first X nodes, find the length, so subroutine to find the length, so the total number of nodes, and then you have a routine that'll, given a certain number of nodes, you'll split into, small list of those number of nodes, ideally, if you can, and then a longer list of whatever's left, and then you just split multiple times until you use all the nodes. That's it. Super simple. Super simple. You could maybe put this up at you could maybe put this variable here, and then also put this variable in here, and then compress this into a smaller loop. Yeah. Obviously, you don't want to split once you hit the bottom, hit the back. So you have sort of a base case type of thing. You actually could even go like this, I think. I tend not to do this, but you could do this too. Let's give that a shot. Yeah, so you can make this even more concise if you wanted to. Right, and you could say amount equals right, and then also, you don't have to yell at me, I noticed you got all caps over there. I can hear you just fine. There's that too. How about this one? If you really want to make it concise. There we go. Yeah, that's pretty good. That's pretty clean. What I meant was, yeah, you're all caps. You don't have to yell. Just want to have a normal debate. Apart from live chat, if you could open comments, I would send my solution. If that's okay with you. It's the not lie my mistake. Brother, I have no idea what you're talking about, but that's okay. We don't have to debate. That's all right. That's all right. I'll concede that you have 1 millisecond on me on your solution. It's okay. It's all right. We can move on to the next question though. All right. So thank you all for watching. Talk to you soon. I'm gonna just start another question, another problem. So thank you. Talk to you soon.